What up, athletes? Whoop, whoop. All right. We're going to start out a little different today. I actually want you guys to write down these vocabs right here. I'm not going to give you tons of time, although before you write them down, please note that if you can, I have put above this video a printable version of guided notes so you know exactly what I'm looking for. And I'm going to flash back and forth to the notes so you see kind of what I expect to be written down as the time goes on. So, with that said, family of graphs are graphs and equations of graphs that have at least one characteristic in common. A parent function is the simplest of functions in the family. For today's purposes, we are going to be focusing on the parent function f of x equals x. I'll talk more about it later, but what's important about this function is every point is in the form a. In other words, 1, 1, 2, 2, 3, 3. It's always going to be the y is, what this means, remember f of x is a fancy way of saying y, because it's just a function of x. Y equals x, so they're always going to equal each other, okay? Translation is a transformation in which a figure is slid from one position to another without being turned, and then a reflection, which we'll talk about rotations as well. Rotations are when we turn things, and then there's reflections is a transformation in which a figure, line, or curve is flipped across the line. Go ahead and pause this if you need to. We're going to move on. Maybe. I can get stuff out of the way, right? All right, now is for our warm-up. Take a minute, and I want you to decide, given each of these options, and I have an area in your focus notes up top, right above the vocab section. Does each situation describe a translation, which is movement, right? A reflection, which means mirror image, or a rotation, which we're turning it, or last of all, a dilation, which a dilation means we're either making it bigger or smaller. So take a minute, look at these. Pause it if you need more time, and then I'm going to show the answers now. So using a screwdriver is a rotation, right? Because we're twisting it to turn it in. Using a sewing machine, it's going like this. It's moving, so that's a translation. The image of the mountain image is reflection. Architectural models, well, they're smaller, right? They're like 1/8 the size or whatever. So that's a dilation, excuse me. And then the movement of cars down a highway, again, that's movement, so that's translation. Awesome. Okay, so I'm going to talk this through, then I'm going to show you on the notes and zoom in for what it is I expect you to have on there. Because we're going to get through a lot of our notes just going through this. We're actually going to go through each of the sections. So if you look at the bottom of your notes, if you printed them out or have a printed copy where it says translations, dilations, then on back it has dilations and reflections. We're going to get through translations and dilations right now. We'll add more later, so don't take up all the room because we're going to do examples in each, but I want to kind of get through them. So right here, we're talking about translations for these first two. So we have the graph of f of x plus k. In other words, we're doing the function and then just adding some number k. So I'm going to reset this because I didn't reset it last time I used it. It's all gone. Let's look at f of x equals k. Now, I want to start off with k equals 0. So if we're not adding anything to the function, it's f of x plus 0, function's the same. What happens if I change my k to a 1? So I'm going to add 1. Notice this point right here did what? It went up 1. So when I added 1 plus 1, I went up 1. What about if I made it a minus 1? Well, that went down 1. So when we're adding x, and this is called outside of grouping, so this is not, we're not grouped together. See how this one's grouped with parentheses? We're not grouping it. We're saying when I add or subtract one just outside the function, and I just am adding or subtracting right off the top, what I'm doing is moving the graph up or down. Up if it's positive, down if it's negative, okay? Now, let's go ahead and reset this again. I want to look at the graph of f of x minus h. Now, all this is, it just means when I put in my x value, I'm going to subtract from the, instead of subtracting or adding to the y value, I'm going to subtract or add to the x value. So in this case, let's go ahead and go to 0 again. Notice if it's 0, nothing happens. But look at this point right here. Let's see what it does. When I'm Now notice it's x minus, so if I put in a positive value for h, it's going to be f of x minus whatever. If I put in a negative value, it's going to turn this to a plus because minus minus makes a plus. But watch this. Let's put in a positive value of 2. What direction do you think that'll go? It goes to the right. We have x minus 2 on the inside when it's grouped with x. So when it's not grouped, it moves up and down. When it's grouped with x, we see it moves to the right. How many did it move? It moved 1, 2 to the right. And that's what our h value was. It was 2. What if I make that negative? Look at that. It moves to the left. You'll notice they left it f of x minus negative 2. I would have changed that to x plus 2. Most of the time in your problems, you're going to see a plus there. So it almost looks the opposite, right? When you're subtracting, you're moving to the right. When you're adding, you're moving to the left. Okay, and again, you move to the left too. There we go. And if I'm looking, I want to take a minute, stop, and show you what I want to see you guys write down, because I'm going to kind of walk you through it. I went and pre-did these notes. And by the way, your paper is going to look just a little bit different than mine. I made some alterations to it after I took notes, but no worries. So let's... If you look right here, let me zoom in. So I just have my vocab, right? Things written down, learning target, and all that. But I want to really focus right here. So what do we notice? First of all, I talked about the parent function, f of x equals x. And I wrote down g of x is the child. We'll be talking about that later. There's not really a child function, but it just means it's an offshoot. It's in the family of functions where f of x is the parent. So translation of f of x, go ahead and write that down. And then not grouped. So f of x plus k, that's not grouped. And we see that f of x plus 1, what did it do? It moved the graph up 1. Make sure you write that down. F of x minus 1, what did it do? It moved the graph down 1. And so what does this tell us? It tells for my k value, when it's greater than 0, it's going to move the graph up. When k is less than 0, it's going to move the graph down. Okay? Again, you can pause this at any time to be able to write down more, but I'm going to kind of go through it fairly quick, knowing that you have the pausing capabilities. Okay. If grouped, we see f of x minus h, where it's grouped. The variable that or the static number we're adding or subtracting in is coming in with the x, so it's grouped with x. So if I have f of x minus 1, it's going to move the graph right 1. If I have f of x minus negative 1, which is really f of x plus 1, it moves the graph left. So whenever you see minus, it's going to move the graph to the right. When you see plus, it's going to move the graph left. Okay. What does this tell me? This tells me for h is greater than 0, right? And that includes decimals. It moves the graph to the right. For h is less than 0, it moves the graph to the left. Now, keep in mind I'm talking about h. And the general form of this equation right here is a minus there. So when I'm looking at h, I'm not looking at the sign in front of it. That's what's hard about this one. You're just looking at the value of h itself. Okay? All right, so that's all we've looked at so far. Make sure you have that down. We're going to move on forward. Let's go back. Okay, I'm going to reset this. Now I want to talk about dilations. Now, what is a dilation? Dilation just means I'm multiplying this graph by something. So I have some number a there. Okay, so I'm going to do 0. Or notice 0 is weird. 0 doesn't work like it did on the other one. 0 makes it 0 because what's 0 times anything? Right? 0 times the function is 0, right? Okay, if you want the identity function on this one, we have to do 1. Because what's 1 times anything? It's itself. So notice when I put 1, it's the same. Okay? Now, I'm going to do a number greater than 1. Let's pick one. Let's go with 3. What does 3 do? Notice how it was like it took it and it stretched it. In fact, if I could find... Ooh, I got a perfect rubber band. Boom. So look at my little view mirror right there if you can see it. I have this rubber band, right? And if I stretch it vertically, notice how it gets steeper. If I stretch it horizontally, it gets less steep, right? So just keep that in mind. What's happening here is we're stretching this vertically when we multiply it by a number greater than 1. In the same way, let's go to a number less than negative 1. Okay? So I'm going to go negative 3. Oh, there we go, too many of those. Notice what happened here. it's really the same slope. Like you'll notice, let's look at the slope. We have lattice point here. So it's up 1, 2, 3, 4, 5, 6 over 1. So it's got a slope of 6. But let's look over here. If I make it positive 3, it's up 1, 2, 3, 4, 5, 6 over 1. So it's still a slope of 6. But the difference is this one has a positive slope of 6 and negative 3 has a negative slope of 6. So it just makes all the y values go negative, okay? But that's getting in some reflection territory. So here's what we want to say. If I'm just talking about numbers greater than 1, then it's just making it more and more steep or less steep, right? 2 is a little less steep. If I have 5, that's real steep, right? What about, though, notice I've been avoiding the numbers between 0 and 1. Okay, so let's put in 0.5. Whoa, that made a huge difference. What if I put in 0.1? I want 0.1. 0.1. It's going to let me do that. There we go. Super less steep. All the way till 0. So what happens is, if the numbers are greater than 1, it's stretching it vertically. If the numbers are less than 1, it's stretching it horizontally. There's another way to say it. Not only is this a vertical stretch, but that's considered a horizontal compression. If we're stretching it horizontally, that's considered a vertical compression, right? We're making it twist more on its side. It's verbiage we'll have right here, but I want to look now and go again to our notes. I've got more for you. So we're going to talk about dilations. This one looks a little weird. Let me talk about it. So what do we have here? 4RA equals 1. So we're just making that equal to 1. 1 times f of x equals f of x. It's the same graph. 4RA equals 2. 2 times f of x stretches the graph vertically. A equals negative 2 stretches the graph vertically. It's steeper, but in negative direction. That's actually, we're going to talk about that. That's a certain type of well, that's a different type of transformation. What if it's 0.5? Well, 0.5 times f of x, it actually stretches horizontally instead of vertically. It's less steep, and that's called vertical compression. And I wrote it down here where it's absolute value a. So in other words, we're just talking about positive values of a. If it's greater than 1, it's going to be a vertical stretch. If it's less than 1, it's going to be a vertical compression. Another way of saying that is horizontal compression or horizontal stretch, right? If absolute value of a equals 1, no change, that's called the identity. All right? So lots of weird verbiage here, but we're going to get through it. It's actually not hard once you get looking into it. It's just a matter of understanding the language involved. Pause this if you need to. We're going to move on to the rest. Okay, so that was a good one. Goes through a lot there. We're going to make some practicals out of this, okay? So translations of linear functions. So we're going to add in, you'll notice you had another couple of, I don't know if there's 1 or 2 vocab words. We're going to fill them in now. Pause it if you need to. So we're going to talk about a family of graphs, which includes graphs and equations of graphs that have at least one characteristic in common. The parent function is the simplest of the function family. Family of linear functions includes all lines with the parent function f of x equals x. That's why I labeled it above our transformations. F of x equals x is the parent function, because any other linear function that comes from that is just a transformation of the parent. The identity, which is also called the identity function. Its graph contains all points in the form AA. So they're all the same, right? 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, right? All the same. It has a domain and range of the identity function are all real numbers. So the domain and range of this, all the possible x and all the possible y, is all real numbers. A transformation is going to move the graph on the coordinate plane, creating new linear functions. So let's get into that. Okay. Here we go. It's a nice little example. So look at your notes to help you. We see, so if f of x equals, I'm just reminding you, if it equals the function plus some number k, not grouped with it, that's a vertical translation. So this one, notice, the 3 is not grouped with the x. If f of x equals x, and we're just doing x plus 3, the constant is not grouped with it, and therefore it's going to be a vertical translation. So if I'm looking at this, this is not. And the result is a vertical. I want you to actually write this down. Write down the function right here, and write down the constant is not grouped with x, and the constant is that 3, right? So the result is a vertical translation. And now let's talk about what it's actually doing. The graph of g of x equals x plus 3 is the translation of the graph of the parent function, 3 units, and it's positive, so it's going up. Okay? And how are you going to write this down? Well, I'm going to show you, because you don't need to use that many words. Let's take a minute and look back. Oh, geez. That. So what I have written down right here under examples. Now you're going to write this. I've made your section over here a lot bigger. So I want you to write this under f of x plus k. I've just got it back here. And so what do I want you to write down? G of x equals x plus 3. This is not grouped. Vertical translation, 3 units up. That's what I need you to write down. Okay? Pause it if you need to. Let's roll. And that covers all of it. Now we're going to talk about horizontal translation. So what is that? That's anything in the form of f of x minus h, right? That's telling us that we're grouping it together. So notice it looks a little different here. So I want you to see it. We'll instead write it as g of x equals, what is it going to equal? Notice how we have grouping symbols around the x minus 7. So that means 7 is my h value. Now even though it's a minus, we're only looking at the 7 for the h. So if h is greater than 0, right, that moves right. That moves to the right. So because of that, the constant 7, or I'm sorry, not 7. Ooh, how do we undo that? The constant is grouped with x. So the result is a horizontal translation, right? Remember, if it's grouped, it's horizontal. And how far is it moving? Well, the graph of g of x equals x minus 7 is the translation of the graph of the parent function 7 units to the right. If it was a plus, it would be 7 units to the left. Awesome. How are we going to look at that in our notes? Let's look. Notice you're going to write this under, this time you're going to write it under this part where it says f of x minus h. You'll have more room to write under there, and this is what I want you to write under there. G of x equals x minus 7. Grouped. Horizontal transition, 7 units to the right. Okay? Awesome. Pause it if you need to. We are almost done. Now we're going to do, and just write these in any extra space you have there in those translations. What if I have it doubled up like this? Notice, now I've got a twofer going on here, right? So the graph of x plus 4 minus 10 is the translation of the parent function, 4 units. Well, it's grouped inside, so that's horizontal, and since it's plus, that means it's going left. It's going to go to the left. On the outside, it's not grouped with the minus 10. So since that's minus 10, it's going 10 units down. Boom, we got it right. Write that example down, pause if you need to, let's roll. And our last deal of the day is this right here. A museum with the total number of people attending can be modeled by the function f of b equals 48b, where b is the number of buses of people. 20 additional people are coming by car. The total number of people on the field trip can be modeled by g of b equals 48b plus 20. right off the bat, I can tell you, is 48B plus 20. Is that grouped? Nope, that is not grouped. There's no parentheses. So that is a plus 20. That means it's a vertical change, and it's going up. So the number of people coming by car to F of B is after the number of people attending by bus is calculated. So the result is a vertical translation. And the translation of the graph F of B, 20 units. And where is it going? It's going up. Awesome. Let's see, did we do it right? I always like to prove. Did I do it right? Yeah. So with that said, that's done for day 1. We'll continue more tomorrow. Peace out.